All right, this is View Calculus. We're doing topic 8, which is the chain rule. So you'll notice in your packet that I point out that there is really no easy way to write the chain rule, right? Because some chains have 2 functions, some chains have 3 functions, some chains have like 4 functions. So it's more of a concept than it is like a simple, oh, hey, it's just these 2 functions and do this thing. That said, I wrote a very simplified version with 2 functions here. If you have some y equals f of g of x, meaning g is the inside function inside some f function, then if you wanted to find y prime, the way you do that is you do the derivative of the outside, so f prime, but you'd leave the inside the same, so f prime of g of x, and then times that by the derivative of the inside, so d out times the derivative of the inside, g prime of x. Now, if I gave you a chain that had, like, let's say 3 layers, let's say I said y was f of g of h of x, excuse me, where h is the inside and g is like the middle function and f is the outside function, then your y prime would get more complicated. It would be f prime of, so you do the derivative of the outside, and you'd leave the inside stuff the same, right? Times the derivative of the middle, g prime of h of x, you'd leave the inside stuff the same, times the derivative of the inside, right? So like this was the derivative of the outside times the derivative of the middle times the derivative of the inside. You can see how it gets more complicated. So there's no one easy way to write the chain rule. What we're going to do is we're going to walk through a bunch of examples, and I think you'll start to get the way it works. Essentially, the chain rule is something you have to use anytime there is a function inside your function. So let's walk through how that's going to work. So we have, I believe, 4 examples, and then you have 4 practice problems. Cool. So in example 1, we have y equals cosine of x cubed. See how that cubed is inside the cosine? Anytime there's a function inside another function, this is a chain rule. So your y prime is going to be the derivative of the outside function. So you're going to do the derivative of the cosine, right? Derivative of cosine of stuff. So derivative of cosine is negative sine of the stuff, right? Times, then you're going to derive the stuff, the derivative of that, the inside stuff, which is the x cubed, so the 3x squared, right? So what's going to happen is, oh, I did something dumb. Yeah, okay, sorry, I just noticed that I made a typo in the packet, but you're going to get that this is negative 3x squared sine of x cubed, okay? That's your y prime. Cool. All right. So again, derivative of the outside function times the derivative of the inside function, right? Cool. So let's do example 2, right? So if we do example 2, sorry for that brief pause, just definitely had a moment where I spotted a typo in my own work. So for example 2, I have y equals tangent of 5x, right? So my y prime is going to be, so again, I have this inside function in the parentheses, and I have this outside function that's tangent. So I'm going to do the derivative of the outside function, which is tangent. The derivative of tangent is secant squared of whatever's inside the tangent, right? Times the derivative of the stuff on the inside of the tangent, which would be the derivative of 5x, which is a 5. So my y prime is going to be 5 secant squared of that 5x. Okay? Cool. All right. So what we're going to do in, well, you know, I was going to do it in the next video, but that's okay. It's actually not worth it. So when a lot of times when you see these, it's because they're inside trig functions, so we already learned the trig derivatives, but sometimes it's also because they're inside an e to the x function. So we're going to learn one more derivative rule. So the derivative with respect to x of e to the x is just e to the x. So you could derive e to the x over and over and over again, differentiate once, twice, 3 times, 4 times, you're always going to get e to the x, okay? So that's another one that's worth making a note card for, even though it seems pretty straightforward. So let's do example 3. In example 3, I'm going to give you y equals cosine of e to the 4x. Well, now I have 3 layers. So I have the inside layer is the 4x, because that's inside the e function. The middle layer is the e to the stuff, and the outside layer is the cosine. So my y prime is going to be the derivative of the outside layer, so the derivative of the cosine of stuff is going to be negative sine of that stuff. I don't change the stuff, right? Times the derivative of the middle layer, which is e to the stuff, right? The derivative of e to the stuff is e to the stuff. I don't change the stuff. Times the derivative of that inside function, which is 4x, so that would be a 4. So my answer is going to be y prime equals negative 4 e to the 4x sine of an e to the 4x. And you don't have to write it in that order, but that's sort of the conventional order that we'd write it in. We'd probably put our coefficient first. All right, one last example, because it sort of tricks people sometimes. So one last example is example 4. In example 4, we have y equals sine cubed of 2x. So the mistake people make here is they accidentally get confused about which function's on the outside. So if you think about how you'd actually enter this if you were putting it in your calculator, this is the whole function sine of 2x quantity to the third. So the inside function is the 2x, the middle function is the sine of that 2x, and the outer function is the stuff that's cubed. So my y prime is going to be the derivative of stuff cubed, right? The derivative with respect to stuff cubed would be 3 stuff to the second, right? Times the derivative of sine of some stuff. Well, the derivative of sine is cosine of that stuff. Times the derivative of the stuff on the inside, which would be a 2. So my y prime ends up being a 6 sine squared of 2x cosine of 2x. And that's my final answer. So you're going to try example or practice problems 1 through 4, and that's pretty much the deal.